Hi, it's Jason Gorman from Codemanship here with the fourth in our video series on test-driven development in Python. If you've not seen the first three videos, I highly recommend you take a look at those first. There'll be links in the description below. In this video, we're going to be talking about duplicate code and the rule of three. And we're going to be demonstrating this using the Mars rover code kata, K-A-T-A. That's just a Japanese word meaning a repeated exercise. Um, and I'm going to quickly explain the problem that we're going to be solving, and then we'll talk a little bit about duplicate code. So the Mars rover kata, again, there'll be a link in the description below to a description of this exercise. But the idea is that we drop a Mars rover onto an idealized grid, a grid of squares, if you like, and we tell it where it is on that grid in terms of x and y coordinates, and we tell it what direction it's facing in, whether it's north, east, south, or west. And then we can send it instructions or sequences of instructions. We can tell it to go left or right, and we can tell it to go backwards and forwards. And we're going to be writing some code to essentially manage our Mars rover so that we can execute those sequences of instructions. And while we're doing that, we're going to be refactoring our code to remove duplication. Now, duplicate code can make our code harder to change because it essentially multiplies and making the cost of a change. So for example, if we repeat the same code 4 times, and then we need to make a change to the common logic in that code, let's say, for example, we copied and pasted it, then we've got to make that change in 4 different places. So it multiplies the cost of change. And that can be bad, but by no means the worst thing you can do in code. But duplication when it comes to design is very, very interesting because the opposite of duplication is reuse. So when we refactor to remove duplication, we often end up introducing generalizations and abstractions, methods and parameters and classes and so on and so forth, through the process of removing that duplication. So we see multiple examples of essentially the same code with slight differences, and then we generalize that into some kind of abstraction. And that's often where we discover the abstractions in our design. So duplicate code often hints at what the design really wants to be. So when it comes to doing test-driven development, as we add more and more test cases and introduce potentially more and more duplicate code, if we refactor away that duplication, a design will often emerge. We discover the design, if you like. So although duplicate code can be a bad thing in terms of maintainability, from a design point of view, it's also very, very interesting. It signposts maybe interesting or useful abstractions. So we're going to be doing this kata, starting with turning the rover to the right. So we're going to write tests for turning the rover from the right, for example, from north to east. So let's write a test for that now. I'm using the built-in unit testing framework that comes with Python. So there's nothing that we need to import yet. And I'm going to write this test assertion first and work. Oh, no, actually, let's name the test first. Always a good idea, I think, to name your test first so it's clear in your mind what exactly are we testing. And I've got a pretty good roadmap in my mind as to the test that we're going to work through. See the previous video on test lists to help with that. So let's talk about turning right. North to east. So we're turning right clockwise. So let's assert. We're expecting it to end up facing east. Let's imagine we have our rover. And as you'll see in a minute, I'm going to be going for a kind of a functional style of Python here. Let's just declare our rover. And what I'm going to be doing is I'm going to declare this as a data class. Don't worry if you've not used data classes in Python yet. They're very, very straightforward. First of all, we tag our class as being a data class. Let me just import that from the data classes package there. And then what we can do is we can declare our data class with fields. For example, we're going to need to know what direction our rover is facing in. And that's just going to be a string, northeast, south, and west. Okay. And what Python will do at runtime is it will generate a constructor passing in the direction. Let's supply that information there so that that is set. And we can also optionally make our class kind of, sort of, because you can't really do this in Python, but you can kind of do this with data classes. We're going to say that our class is frozen, which means that the values of these fields are going to be essentially immutable. If we try to change them, it'll throw an error. So we have an immutable data class there. And what we need to do is we're going to tell our rover to go to the right. So it starts, oops, no, it doesn't start facing north. It starts east, sorry, it starts facing north. So it's facing north, and we're going to tell it to go to the right. And at the end, it should be facing east. Let's generate that method. And we'll call that the instruction. Okay. And if we run this test, we'll see that it fails because we're not actually turning it. Okay. Let's just check and see why our test is failing. It's a good idea to see that your tests actually fail. Has no attribute facing. That's interesting. Why do you have no attribute facing? Not quite sure why that's happening. Yeah, we haven't actually set it here. So no, that should be working. Go equals north. Function go doesn't return anything. That's why. So let's just return ourselves for now. Yeah, so we were returning a null object there. Okay, so now our assertion is failing. The values don't match. So we're expecting it should be facing east, and it's still facing north. So to get this to pass, what we can do with an immutable data class is we can use this replace function that is part of our data classes package there. And what we do is we say we want to replace this object, which in this case is this instance. And then we can say, but we want you to change the value of this field to east. And that should pass. So we get a copy of this object with the facing field changed from north to east. And there we go, we've passed. So far, so good. It's time to think about refactoring. Our rover class doesn't really belong here, so let's move this to its own file in the root folder. Okay. So far, so good. Right, so at the moment, we don't really have much in the way of duplicate code to worry about. Let's just open that file there so we've got it handy for us. So we don't have any duplicate code. There's not much else I would really bother about refactoring at this point. So let's move on and write another test. And this time we're turning right from east to south. So again, we're going clockwise. Write the assertion first and work backwards. And this time we're expecting it to end facing south. So you probably can see that this test is already starting to look very similar to the first one. So there's a bit of duplication emerging here. Let's declare our rover. And let's have it initially facing east. And let's tell it to go to the right. Okay. And if we run this test, again, we should see it failing because it's going to end up facing east. Okay, that's exactly what we expected to happen. So what can we do that would be simple and would pass this test quickly? How about we just branch for now? So if we're facing north, then we can do that. And if we're, well, we don't even need another if, do we? We can just say, okay, and if we're not facing north, then make it face south. Simple as that. And that should pass. Let's just reformat that code. It seems to be happier when they're closer together like that. Okay, lovely. So back to our test. So now we have two tests that are very, very similar. The only thing that's different is what direction we're facing in to begin with and what direction we end facing in. So I could refactor this test code now because it is very, very similar. And we'll talk a little bit about how we could do that, a simple way of doing that to remove this duplication. But I'm not going to yet. And the reason I'm not going to is I like to see potentially more examples of duplication before I jump in and refactor it into some kind of abstraction. And the reason I do that, the reason I might wait to see more examples, is because there is a danger when we refactor duplication too early that we end up introducing the wrong abstraction. We basically we come up with the wrong pattern. So there is this rule called the rule of three. It's not hard and fast, but we tend to find that you usually might wait on average to see three examples of duplication, three examples of the same thing before you refactor, so that you're more likely to end up with a good abstraction rather than jumping in too early and essentially getting the abstraction wrong. One of the biggest sources of what we call leaky abstractions, these are abstractions that don't work for subsequent cases, is that we got in there too early and we sort of speculated about what the pattern was, about what was the same, and then it turned out that was not the case. So the rule of three is we wait to see three examples of duplication on average before we refactor so that we have a better chance of introducing the right abstraction. Now, the flip side of that is if we wait too long, if we produce too much duplication, that refactoring will take longer, and the longer something takes, the less likely we are to do it. So if we leave it too long, if we wait for the fourth or the fifth or the sixth or the seventh example of that duplicate code, the danger is that we'll never get around to actually refactoring it. So rule of three, don't jump in too early when you're not maybe not so sure what the pattern is. So you introduce the wrong abstraction, but don't leave it too late that you end up with a much bigger refactoring, which means you're less likely to do it. So rule of three, basically. So we've got two examples here. I'm quite happy at the moment with the implementation. It's fairly straightforward, but there is a pattern emerging. I can't quite see what it is yet, but there is a pattern emerging. So let's go on and write a third test. Let's test turning right. This time we're going from south to west. Insert first and work backwards to the setup. So we're expecting to end up facing west river. And let's declare our rover here. And we'll make that face south to begin with. So we're going from south to west, clockwise as again. Now let's make it go. Go to the right. Okay, when we run this, we should end up still facing south. There we go. Yeah, it's expected west, but it's actually still facing south. So again, what's the simplest thing we could do here? Well, we could introduce another branch. Oops. So we're facing east, make it face south. Otherwise, make it face west. Let's run our test, see what happens. Lovely. Tests are passing now. Now we have three examples here, going from north to east, east to south, and west, south to west. So there is a pattern emerging here, depending on which way you're facing to begin with. You'll end up facing sort of the next one round, if you like. If you imagine we had a list of directions, call it a compass. And let's do this refactoring now. So imagine we have a list of directions, north, east, south, and west, all in the right order, going clockwise. So we've got that compass there, and we can figure out where in that list and what index, what position on that list we're currently facing. So we can use index and ask which way are we currently facing, where in that list is the one that we currently point to. And then all we need to do is move on to the next one in the list. So from our compass, it's the current direction plus 1. So let me just run that. So that should still work, yep, which means that all the code below can now be replaced. So we can get rid of this quite subtle duplication, but it certainly is duplication. Let's run our tests again. Okay, so we've removed some duplication from the implementation there, and that's going to make life a little easier going forward, as you will see. But also we have quite a lot of duplication in our test code. Remember from previous videos that test code is code. It needs to be maintained just like the source code. And if our test code, for example, is full of duplication, then we're going to have a problem going forward. Now, these 3 tests are all examples of the same thing. They're all examples of moving to the right clockwise. So what we could do is we could parameterize this test. So what we're going to do is we're going to introduce parameters to one of these tests, and then we can feed in test data. So we have one test method for moving right, and then we have 3 test cases. And to do that, I'm going to be using a separate framework, a separate library from unit test called parameterized, which I'm going to import using pip. So let's install that parameter. Right. Now there's a fair amount to this library, but we're just going to be using the basic features. Let's import that. Okay, so that's installed. Now what we're going to do, we're going to have to kind of do this in a couple of steps maybe. First of all, let's use our first test as the kind of the template here. So we're going to use this parameterized attribute there, and need to import that name from the right library. There's many versions of it now. Be careful which one you're using. I'll put a link in the description below to the documentation for this particular parameterized framework. Expand, and what expand will do is it will take an array of tuples. There's an empty tuple just to begin with. An array of tuples, and each tuple, as you will see, will contain the test data for each test case. So each tuple in the array represents one test case. Okay, now the reason I've done that like that so that it currently doesn't do anything is just so that I can run this and see, yeah, it's still working, that's fine. And now we can start adding parameters. So there's one parameter. And let's call that's our ends facing. No, starts facing. Sorry, starts facing. So that's the direction it's facing in to begin with. Okay, and we'll do it all in one step. Ends facing. So we've parameterized our test, and now what we do is we supply the data to match the parameters, so the right number of parameters of the right type in the right order to match the parameters of this test method. Let's just save that. So when I run it again, I've essentially replaced the original test with a parameterized test. So it's running the same test, as you can see. Let's just put it down there. We've still got 3 tests, but now it's running the first one as a parameterized test. So the test data is being fed in to these parameters, and we don't need those anymore. the framework should be able to do it automatically, automagically, as it were. Now, what we can say is, let's generalize the name. It turns right clockwise. Rerun that test. And now we can start replacing the other test methods with test cases. So from east to south and from south to west. Still all passing, lovely. But now you will see we've got a bunch of these test cases. So we created a couple of extra ones there. And they're essentially asking exactly the same question as these two standalone test methods here. So let's get rid of those because that's duplication. And the duplication is gone. And what we've got now is a single test method for those three duplicated similar examples of what is essentially the same behavior or the same rule. Now that we've done this, it's very, very easy to add a fourth test case to finish off our circle, if you like, going from west back to north. This is going to fail because it's going to go over the edge of our list on our compass. So to make this pass, we need to stop it from going over the edge here. So when current, for example, is 3 and we add 1 to that, that's an index of 4, and that means it's going to be out of bounds. So how can we stop that? Well, a simple way I can think of might be to use modulus. So essentially what we're saying is every time it goes over an index of 3, reset it to 0. So every time it gets to 3 and we add 1, go back to 0. So we go round in a loop and we run that and our test passes. There you go. So we removed some duplication. That pointed us towards a more flexible design and a simpler design. And we also removed some duplication from our tests. We took that opportunity, and in doing that, introducing that parameterized test, it was much, much easier, far less code, to add another test case. So removing duplication points often towards good abstractions, as well as helping potentially to make our code easier to maintain. The rule of 3, remember, an average of 3 examples of duplication before we refactor. Sometimes you can see the pattern straight away. Sometimes you need to see more examples, and that's fine. It's just a rough average. But what we're saying here is don't jump in too early. Wait until you can really see the pattern before you generalize or before you introduce an abstraction like our compass. And don't leave it too long either. The longer you leave it, the more examples you're duplicating, the harder that refactoring is going to be, and the harder it is, the less likely it is that you will do it. Now, there's one more thing that I want to talk about to finish this video, and that's when don't we remove duplication? Now, we have a parameterized test here, and we could adapt this test, for example, to test turning to the left. So we could add, for example, another parameter that says, okay, which way are we turning? Turns, and then we could add that as another parameter here. Let's do that. All right, so these are all to the right. And then we could say, okay, what if let's just run those and make sure they work. Thank you. What if we also want to add another test case for turning to the left? So we would go from the left from north to west, for example, as another failing test. It'd be very easy now to add more test cases for turning our rover. The danger of that is if we add examples of what are essentially a different behavior, when we turn to the right, the rover turns clockwise. When we turn to the left, the rover turns anti-clockwise. It's a different behavior. And the danger now is that essentially we're overloading this one test method with multiple behaviors. It means multiple things. So we might have to rewrite our test name for it. Turns right clockwise and that should be a bit of a giveaway, turns left anti-clockwise. clickwise. Now, the danger here is that as we do more and more of these, our test code is going to get harder and harder to follow. I'm very much in the habit of kind of stick to the rule of thumb of having one test method per rule or per behavior. So that when we're reading our test code, it reads like a very simple specification. So we would not reuse this. We would start, we would start with a new test method. We would say, okay, let's write another test. Test, turn left or north to west. So we kind of begin this process again. We're going to be introducing more duplication, and then we will refactor those duplicate tests into their own parameterized test that describes the rule that they are all examples of. So we end up with a test fixture that has some duplication in it, but is easier to understand. And that is the exception. There are times when we remove duplication and we get a bit too clever for our own good, and we end up with code that is harder to follow. So the exception to the rule of removing duplication, the exception to the rule of three, is when after removing the duplication, we read the code and we think, you know what, this is harder to understand. In which case you would revert that and leave the duplicate code in. And I've seen many, many examples of that. So that's three things that we've learned in this video. Number one, removing duplication from our code and from our tests often leads to useful abstractions and signposts what the design really wants to be, what would be the best design that would pass these tests. So it is something that is well worth paying attention to. The rule of three is a rule of thumb that says maybe we shouldn't jump in too early and remove the duplication because we might end up with the wrong abstraction. But also maybe we shouldn't leave it too late so we end up with so much duplication that we're probably not going to get around to removing it. And then finally, we've looked at how we might choose to leave some duplicate code in, both in our source code and in our tests. Leave some duplicate code in specifically because it makes the code easier to understand. So there you go, that's video number 4. Links in the description below. I look forward to seeing you in video number 5.